In this example, we're going to look at building a table of reduction potentials from experimental data when that data is presented as a series of reactions. So in this question, we have 4 reactions. So in our first reaction, we have cerium 4 plus and palladium solid. Now, if you recall, solid metals are typically reducing agents, and metal cations are typically oxidizing agents. So I'm going to highlight our oxidizing agent here in blue and our reducing agent in red. In our second reaction, we see that we have palladium 2 plus and indium 2 plus, and we see if we look at the products that palladium then goes into a solid. So palladium has been reduced, making palladium 2 plus our oxidizing agent and indium 2 plus our reducing agent. In our third reaction, we have cadmium 2 plus and palladium solid. So cadmium 2 plus, the ion, will be our oxidizing agent. Palladium solid will be our reducing agent. And in our final reaction, indium 3 plus will be our oxidizing agent, and cadmium will be our reducing agent. Now, if you look at the information here, we see that the first 2 reactions have products listed. That is because reaction 1 and reaction 2 are spontaneous reactions. The last 2 reactions, 3 and 4, do not have products listed, so those are non-spontaneous reactions. So we're going to start with reaction 1 and go from there. So reaction 1, we know that because cerium and palladium undergo a spontaneous reaction, our oxidizing agent is going to be above our reducing agent. So in this case, cerium 4 plus, so I'll write that here, cerium 4 a full half reaction. So we know that the other half of that is palladium 2 plus, and so that's going to gain 2 electrons. So that's reaction 1 done. Reaction 2, palladium 2 plus reacts spontaneously with indium 2 plus. So that means, again, that my oxidizing agent, palladium 2 plus, is above my reducing agent, indium 2 plus. So I already have palladium 2 plus, so again, I'm going to leave a little bit of space, and I'm going to write indium 2 plus in my reducing agent column, and I'll just finish off that half reaction. So indium 3 plus is the OA, and it's going to gain an electron. So that's reaction 2. Reaction 3 tells me that cadmium and palladium have no reaction. So palladium solid is going to be above cadmium, but I don't know if cadmium is above or below indium. So I need to look at reaction 4. Reaction 4 tells me that cadmium solid and indium 3 plus have no reaction. So this tells me that my OA is lower than my RA. And that means that cadmium is going to slide in between palladium and indium. So cadmium 2 plus is the other half of this. So it's not the neatest table we've ever drawn. We could definitely squish it together at this point, but we have ranked everything. So our strongest oxidizing agent is cerium 4 plus, and our strongest reducing agent is indium 2 plus. And if we just double check, cerium and palladium will be spontaneous, so that's correct. Palladium 2 plus and indium will be spontaneous. Cadmium 2 plus will not be spontaneous with indium or with palladium, and indium 3 plus will not be spontaneous with cadmium. So you can double check after you've built it that it matches your experimental results.